The following problem states a 12.8 gram piece of iron is carefully placed into a graduated cylinder containing 10 milliliters of water. What is the final reading on the graduated cylinder, and how will a 12.8 gram piece of copper raise the water in comparison? They also provide us both with the densities of iron and copper in the problem in grams per milliliters, with iron being 7.87 and copper being 8.92. So when we're approaching this problem, we want to think about a few things. What is the problem asking? Okay, the following problem is asking what is the final reading on that graduated cylinder. So what happens when we place the piece of metal into the graduated cylinder? How will this water raise as a result of being displaced? Okay, so we have to think about what that means, but we're looking for that final measurement value on the graduated cylinder. They provide us with the mass of iron, which is 12.8 grams for iron. They also give us the same mass because they want us to do this step twice for copper, which is also 12.8 grams for copper. And then they give us the initial volume, which was 10.0 milliliters. That's going to be the same case in both of these situations. Okay, now that we've written down the information that we were provided, we can go ahead and approach this problem. Well, we know that density is equal to mass over volume. Well, they gave us density for each of these metals. So what we have the densities right here. So we were provided the density for each of these. We were given the mass, but we don't have the volume of that piece of metal. So we can use this relationship to find that. So let's go ahead and rearrange this. So we'll multiply each side by volume, multiply each side by volume. Volume cancels out. We'll divide both sides by density. We'll get volume is equal to mass over density. So we'll use this relationship moving forward for the rest of the problem. Okay, and so we're going to look for this volume of that piece of metal. So we're going to put 12.8 grams in our numerator divided by our density for iron, which is 7.87 grams per milliliter. Grams and grams cancels out. Because milliliters is being divided in the denominator, it will come up into the numerator. Make sure you review those types of relationships. And this will be equal to 1.6264 milliliters. We have to consider how many significant figures should be reported. We had 3 significant figures for a measured value. So we should only report, or only 3 places, or 3 of these figures will be significant. The next step that we have to do is we have to find that final volume. That's what we're looking for. Well, how are we going to do that? We're given an initial volume. We found the volume of the piece of iron. So how would we find the final volume? Well, if you were thinking you just had to add the 2 values, your initial value plus your final volume, you were correct. So if the total volume for that displacement, in order to find the final volume, would have been 10 milliliters plus 1.6264 milliliters. Keeping in mind the number of significant figures for this, we will only report out to one place after the decimal. If it makes it easier to line up the decimal as such when you're doing this type of operation. When we're doing addition, keep in mind you have to line up the decimal, and you're only reporting out to the least number of significant places after the decimal. So in this case, 10 milliliters, it was only 10.0 with one place after the decimal. So that was the least number of decimal places. So our final answer will be equal to 11.6 milliliters for that of iron. Okay, so now that we've determined that, we can do the same thing for copper. It'll be slightly different. Make sure to include your units. going to go ahead and just erase. I shouldn't have erased that, but that's fine. I'll write it again. We're going to be doing the same steps. We'll start with density, mass over volume. We're looking for volume of our metal. Volume cancels out by multiplying it to each side. Divide each side by density. And we will get volume is equal to mass over density. So we can go ahead and solve the problem in the same steps. We are given the density for copper. We have the mass, so we have mass of copper is 12.8 grams of copper. Density of copper is going to be that 8.92 grams per milliliter. Grams and grams cancels out. Because milliliters is being divided in the denominator, it will come up to the numerator. And this will be equal to 1.43949, 1.4349 milliliters. Go back, we look to see how many significant figures we should be reporting out to. It should be 3 significant figures. So this final answer would be 1.43 milliliters. The next step that we have to do is find that final volume for that displacement of water. And we're going to do this by adding it to the 10.0 milliliters. Keep in mind you keep all your figures until the very end. When you're reporting out, we'll add this together and this will be equal to 11.4 milliliters. We see that the final volume is going to be higher for iron in comparison to that of copper. So that is how you approach this problem, kind of really taking a moment to think about what these problems are asking and kind of setting up a process on how you would approach it. And always make sure you identify what is given and what are your steps and how to approach it as well. Thank you.